All right, we're back. We are on page 4, notes 15 of Calc C. We're doing integrals by trig substitution. It is not actually an AP calculus topic. Definitely, I think, should be a Calc 2 topic. So that's why we're doing them. But, like, you never know. So this integral is lacking a radical. So we'll engineer one. We're going to make it radical 1 plus x squared. Squared. Oh, my God. Squared. Dx. All right, so now we have our radical and we draw a triangle. Hopefully, I mean, we're getting like, nobody could want that to be that. Like no one on earth would have drawn what I drew and then think like, oh yeah, that should definitely just be a dot. All right, here we go. So that's gonna be radical 1 plus x squared. I think we're getting pretty expert at this point because it just takes practice and then watch me get all of these wrong. Let's see. So tangent of theta is x. That's good. So dx is secant squared. It's like the powers of secant start rising as you do these things, and that's not always that great. Like right now, I'll have tan squared, secant squared, d theta in the numerator, but you know, let's see where it goes. So then the radical is actually just secant, so we're gonna get more of those. All right. A lot of subbing to do. So this is going to go here, and then this is going to go here, and then this is going to go here. All right, let's do it. So actually, we're going to end up with no secant, which is nice. I think we're going to end up with an integral that we've done before, actually, which is ideal. So we get tan squared. And then dx is secant squared d theta. And then the radical thing, but I have to square it, is another secant squared. So I just have the integral of tan squared, but we've dealt with that, right? That's going to be the integral of secant squared minus 1 d theta. The integral of secant squared is tangent because the derivative of tangent is secant squared. And then the integral of 1 is theta because it's 1 d theta, right? Not 1 dx. So that's actually a place where people will make mistakes. Don't make that mistake. You always have to look at your differential to see what the independent variable is. It's theta for this integral. And now we can go back though. So tangent is this over this. Well, that's weird. So that's just x. And now I'm starting to get nervous. And then theta is inverse. What are you doing? Is inverse tangent? Inverse tangent of x. So minus tan inverse of x plus c. Does this like feel right? The derivative of inverse tangent is 1 over 1, and that's 1. Why would that be squared? This feels very wrong. 1 over 1 plus x squared. So it's like 1 minus 1 over 1 plus x squared. That wouldn't. Why would I get 1 plus x squared squared in my denominator if that's happening? Tangent is that. I don't think this is. I do not think this is right. Let me check it. It just doesn't make sense to me. I mean, maybe it is, but I don't think so. Integral of x squared over quantity 1 plus x squared squared. I mean, it just seems too simple. Yeah, there's something wrong. There's a lot wrong because it should be over 2 and like whatever. All right, so now it's like a moment where like, do I want to try to fix it while everyone's watching, or do I just want to start over and act like I knew what I was doing to begin with? I mean, I want to just start over, but all right. Well, if we drew a triangle correctly, this is like we're gonna workshop this problem here. If we drew a triangle correctly, which I think we did, x1, sure, that would be the square root of 1 plus x squared, absolutely. Tangent is this over this. So tan of theta is that. Definitely. Then we got to square it. So that's tan squared. So far, so good. The derivative of tangent is secant squared. So dx becomes secant squared theta. And then this, we had to square. Oh no, I found the problem. It should be to the fourth. So this should be to the fourth. So this is terrible. That should be to the fourth, which means this should be the radical thing to the fourth. This should be to the fourth, which means that I should have gotten tan squared over secant squared. Okay, how do I save that? This should have been tan squared over secant squared. Oh boy. I just got to tell myself, like, hardly anyone's ever going to watch this video. So it's all right. Is it? I hope this doesn't let anyone astray, but you should still be watching, you know? All right, so now how do I fix this? Well, tangent is 1 secant squared minus 1. So let's do that. Let's go with secant squared minus 1 over secant squared. All right, this seems more appropriately difficult, perhaps. So this will give me theta, and then I'm going to do minus 1/2 the integral of 1 plus cosine of 2 theta, because every time you see cosine squared, you replace it with 1 plus cosine 2 theta over 2. So this will be theta minus 1/2 theta. That's interesting. And then it's like, was there a way we could have avoided that? Like maybe not. Minus 1/4 the sine of 2 theta plus c. But then sine of 2 theta. So this is actually just theta over 2. Sine of 2 theta is 2 sine theta cosine theta. So this will be minus 1/2 sine theta cosine theta. This seems better. So theta is the inverse tangent of x. So that's going to be tan inverse of x over 2 minus, so cosine, or back to the triangle, cosine is this over this, and sine is this over this. So it's going to be x over 1 plus x squared. X over 1 plus x squared. That's not right. Oh, maybe it's x over 1 plus x squared. Oh, I see what I'm saying. It's x over 2 times 1 plus x squared plus c, I think. Let me just check that one more time. So yeah, sine is this over this, and cosine is this over that. So it is x over 1 plus x squared. Is that what the calculator had? Let me just like visually inspect this. Minus 2. Yes, it is. Okay, so got it eventually. And that's, honestly, I'm gonna leave it because that's how you do these problems. You like stumble and then you come back and you hope that it worked. And like, I have absolutely no idea if this next problem is gonna take a long time or not take a long time. And all right, I'm gonna go for it. This might end up really long if I mess up a lot, but who knows? Triangle. Yes, we're off to a good start. 3, I'm gonna put the radical here. Why? Because I feel like it. And maybe that's a poor choice. We'll find out. So x is 3 cosine theta. I'm feeling good because, all right, well, we got a negative and I don't like those, but sines and cosines are like easier to deal with. So we'll see. And then the radical 9 minus x squared. So sine is that over 3. So this will be 3 sine theta. All right, let's sub. So this will go for this, and then this will go for this, and then some other color. This will go, too much. That. Here we go. So I mean, to go back to the other one, like, I don't think it's bad for you to see me make mistakes because everybody does it. And then you get to see how I deal with it when I'm trying to fix a mistake. And sometimes the right thing to do, not the right thing, but sometimes the easiest thing to do, why am I writing secant, is to like scrap the entire problem and just start over, which is like often what I will do. But you don't really see that because I also scrap the entire video when that happens. That's like really disappointing. All right, what do we have? We have 3 to the 5th. I got negative 3 to the 5th. And then the integral of cosine cubed and sine squared. Seriously? Powers. All right, so I'm going to save a cosine. Negative, what's 2 to the 5th? 2 to the 4th is 81, so it's 243. All right, save a cosine, and we'll turn cosine squared into 1 minus sine squared. And then sine squared. And then cosine is what we saved, d theta. All right. So the reason that happened is that we took cosine cubed and made it cosine squared times cosine, and then I changed cosine squared into 1 minus sine squared. And now I'm basically doing a u substitution where, like, if u is equal to sine of theta, then du is going to be cosine of theta. And you know what the best part is? It might be wrong. I don't think it is, but, you know, based on that last problem. So this is 1 minus u squared times u squared du, negative 243, the integral of u squared minus u to the 4th du. Sometimes I forget to integrate there, so I'm going to try not to do that. Negative 243, 1/3 u cubed minus 1/5 u to the 5th. I'm going to go on record right now saying I do not think the calculator's answer will look like the answer that I get. So this is u is sine of theta. Okay, so this answers in terms of u is equal to sine of theta, but sine of theta is this over this. So radical 9 minus x squared over 3. Wow. Okay. So negative 243. I'm going to write a lazy version of the answer. Radical 9 minus, what was it? Radical 9 minus x squared over 3 cubed. So, you know what? 1/3 radical 9 minus x squared over 3 cubed minus 1/5 radical 9 minus x squared, gosh, over 3 to the 5th plus c. There is so much cleaning up you can do there because there's like a lot of 3's in the denominator, and then there's like a 3 here, and then like this thing cubed, this thing to the 5th, you can take out that thing cubed, and you're left. So I'm going to check this by taking the derivative of my answer, which even that I don't want to type in. Let me see. Derivative negative 243 quantity 1/3 quantity. I'm just going to call this u. I'm not even going to do a quantity. I'm going to do u cubed and then minus 1/5 u to the 5th. I don't know what the order of operations on this is going to be, but that's what I wanted, comma x, such that u equals square root of 9 minus x squared over 3. I don't know if this is going to work. I think it will, but oh my God, the joy that I'm experiencing. Like, I know it doesn't seem that way. It's more like relief, I guess, than joy. We got it right. That's definitely right. So I'm not going to try to simplify that answer. It definitely does simplify. Here, let's do this. Let's do the integral of the answer and see what the calculator says it is. Like that. Like I would have gotten there eventually, but like it would have taken forever. So good answer. Just depends on what you want your answer to look like. I'm more than content to just get to where we got, because I don't know if the algebraic simplification is the point of this problem. I don't know the point of this problem other than practicing, but we got it. All right. So I will be back in the next video. I think it's mostly a review, and I will see you there.